Alright, so if you're in class, you should have started this already, so go ahead and skip ahead to where we left off. But here we go with the last section of trigonometry. So here's some new formulas. So we are skipping some formulas in this section. We're not going to do like every single formula. Even some of these aren't that used, but these ones are. So anyway, sine 2 theta can be turned into 2 sine theta cosine theta. So it's just like another replacement. If you see sine 2 theta, you can replace it with that, just like all the other formulas. Cosine 2 theta can be changed into cosine squared minus sine squared. Now, this is kind of annoying because this actually has 3 different things it can turn into. Depending on the situation, you might want to use any particular one. So remember that, sine squared plus cosine squared equals 1. So I could replace cosine squared with 1 minus sine squared. So if I did that, I would have 1 minus sine squared again. So then that means it would be 1 minus 2 sine squared. So this can become that. And so depending on the situation, maybe you'd like to use this problem instead of that. It doesn't matter. And then another replacement for it is to replace the sine squared. Well, so I got cosine squared minus sine squared is replaceable with 1 minus cosine squared. So what I would end up getting with that would be cosine squared minus 1 plus cosine squared. So I'd get 2 cosine squared minus 1. So all these things are on your formula sheet on the blue card, but it's just difference in like when you'd want one versus the other. Like it's just interchangeable. Alright, so here tangent is a fraction. It is 2 tangent theta over 1 minus tangent squared of the angle. Okay, so we don't use these a lot for evaluating items because everything that we know on the unit circle, we also know double of it. So like if I ask you for like the sine of 300 degrees, well 300 degrees is already double 150 and I already know 150. Alright, so this one's not really used that much for these kind of things, but we're just going to do it here so you can see it. So sine of 60. So you'd have to realize that 60 is really just 2 times 30, of course, right? So 2 times 30. So look at what's going to happen. So 2 times 30. So right now 30 is my theta. So the 2 is going to be here, and the 30 is going to go here and here. So 2 sine 30 cosine 30. And frankly, I would never do that here because I already know the sine of 60 degrees is radical 3 over 2, but it's just showing you how it works. So 2 sine of 30 is 1/2. Cosine of 30 is radical 3 over 2. So my 2's cancel, and we get radical 3 over 2, which we actually knew was going to be the answer anyway. Okay? So it's just how it is. All right, so example 2. We're solving this equation. So I just have a new replacement. So I now know that sine 2x is replaceable with something else, right? So 2 cosine x, and sine 2x is replaceable with 2 sine cosine. And now that I've replaced it, that irritation right here went away, and when I look, I'm like, oh look, they have cosine in common, and frankly they also have a 2 in common. So 2 cosine x is going to be taken out, which leaves me 1 plus sine x. So I'm factoring, and I'm just going to set each part equal to 0. So you set this equal to 0, you get cosine equals 0, and over here you get sine is equal to -1. Alright, so when is cosine 0? Cosine, the x value is 0 here and here. When is sine -1? So that's down here. So actually, this answer is encompassed in this answer. So I could say this. And it wants all solutions. So I could say pi over 2 plus 2 pi n. And the other answer is 3 pi over 2 plus 2 pi n. But I could also condense those together. They're happening 180 degrees apart. So I could put this into one answer of pi over 2 plus pi n. So any way you want to write it. You can write these two separate, or you can write this as kind of together. Alright, so example 3 here. Again, we're going to be solving. So I have a replacement for this guy right here. So I'm going to be replacing that with my formula there. So I got, let's see, 2 tangent theta, or b actually, over 1 minus tangent squared of b is equal to 2 tangent b. Alright, so let's cross multiply here. So, because I have a fraction equal to something, so I'm just going to multiply this over there. So my 2 tangent b is going to stay. And when I multiply these two things, 2 tangent b times that is 2 tangent b, because times 1, minus 2 tangent b times tangent squared would be 2 tangent to the third, beta. Alright, so look at this, these cancel. So I got 0 equals negative 2 tangent to the third. So I might want to stop a second and look at the algebra. You got 0 equals negative 2 something to the third. Well, the negative 2, I could just divide that out, so x to the third equals 0. So basically I have tangent to the third equals 0. I would take the cube root and I would get x equals 0. So I would basically say here that tangent equals 0. And when does tangent equal 0? It equals 0 at 0 and pi. So my answer would be that b equals 0 and pi, because I'm just doing it in the first circle. Alright, so number 4, we're going to be verifying. So just look on the other side. Notice I could factor out a cosine if I wanted. That wouldn't really do anything. I mean, I don't see anything apparent in that. That would change to something else. Like if I took out a cosine here, I would have 4 cosine squared minus 3. So that's not really anything. So I'm just going to leave that side alone. Over here, though, there's a replacement I can make that you might not be familiar with, but you do have to do sometimes. Cosine 3x, we're going to change that to cosine of 2x plus x. So all I've done is separate it. 2x plus x is 3x. And so now we're going to pull in what you did in section 5.4. So we're going to use that with what we already know, because I learned some stuff for the 2x today. But last time in 5.4 we learned how to separate this. So when you have addition with cosine, you break it into cosine of 2x times cosine of x, and then you change it to a minus, and sine of 2x, sine of x. All right. So now we have replacements. I have a replacement for this guy, and I have a replacement for this that I've just learned today. So back here I got 2 sine cosine and another sine. So I'm just replacing this. And right here, I'm not quite sure which one I want to use. I do see my answer has all cosines. So when I replace cosine 2x, this is what I'm talking about. I think I'm going to use this one here, because I don't want any sines in my answer. So why don't I just use the one that has things that I want. So I'm going to replace cosine 2x with 2 cosine squared minus 1. And then there's a cosine here. All right, so this became that. Okay. All right, so let's multiply this out, see what we got. All right, so cosine times 2 cosine squared would be 2 cosine to the third minus cosine. I'm just distributing. Here, if I clean this up, I got sine squared, cosine. All right, so we're getting there. Cosine to the third, look, I have some going on. Cosine x, look, I have some, but I'm not quite done, because, oops, I forgot an x here. I don't want this. I don't want any sines in my answer, so let's change it. So 2 cosine to the third minus cosine minus 2, I'm going to change that, and I have a cosine still. Okay, so sine squared. So up here, sine squared is replaceable with 1 minus cosine squared. All right, so 2 cosine to the third minus cosine. Here, I have a 2 and a cosine, so I'm going to say minus 2 cosine. Then I have a negative 2 times a negative cosine, so a plus 2 cosine squared, but I got another cosine, so that's 2 cosine to the third. All right, and I think you can see we're done. 2 of these plus 2 of those is equal to 4. Okay, and then -1 and -2 would be -3. So if I had more space, I would write it there, but I think you can see that we've got our answer. So, yay. All right, I know it's getting a little dry, but we're gonna keep going here. Sorry, it's a little boring, maybe take a break. All right, so then you have these power reducing formulas. So these power reducing formulas, you actually use these in calculus quite a bit, especially the one for like sine squared and cosine squared. So you know sine squared is equal to like 1 minus cosine squared, but there's another formula for it. It could also be equal to this, 1/2 and 1 minus cosine 2 theta. Now you could write that way, or you could write it like this. You could also write it as 1 minus cosine 2 theta all over 2. So you could bring the 2 out front and put it in front, or you could leave it like that, depending. It doesn't matter. Over here, it's the same thing, except it's 1 plus cosine 2 theta. So you could also write it like this, 1 plus cosine 2 theta over 2. So it doesn't matter how you write it, that's just how it is. And then over here, tangent squared, you don't use a lot, but 1 minus cosine 2 theta over 1 plus cosine 2 theta. So you can tell, you know, tangent is the sine over the cosine. So if you put these over each other, you can kind of see how it makes that. All right, we're not going to do example 5. Let's just not do that one. Okay, example 6 here. So, example 6. You can actually do this 2 different ways. So I'm going to do it both ways. We are solving an equation here, so let's do it. So first of all, I could do it with this. Cosine squared, we just learned a formula for that right here. All right, so I'm going to put this one. So cosine squared is replaceable with that. So 1 plus cosine 2x, or x is here, not thetas, over 2 minus cosine 2x equals 1/2. So this is my equation. All I did was replace this. Okay, replace that. Okay, so let's see. Look, I got some common terms here. So why don't I just multiply? I have these fractions. I don't like that. So I'm just multiply everything by 2. So when I do that, this goes away, and I get 1 plus cosine 2x. Multiply this by 2, so minus 2 cosine 2x. Multiply that by 2, I get 1. All right, so look at this. My 1's go away. Cosine 2x minus 2 cosine 2x is minus 1 cosine 2x, but now it equals 0. So cosine 2x equals 0, and we will find the solutions to that. So when does cosine equal 0? Cosine equals 0 at pi over 2 and 3 pi over 2. So we will say 2x equals pi over 2, and 2x equals 3 pi over 2. Remember, plus 2 pi n. But we have to fix our answers, so we have to divide everything by 2. So my answers become pi over 4, plus divide that by 2, get pi n, and 3 pi over 4, because dividing by 2 is like multiplying by 1/2, plus pi n. All right. There we go. All right, so that was a decision there. I replaced cosine squared with that. But let's go back to earlier today. Another way I could do this, why don't we leave that cosine squared alone? And let's replace the cosine 2x. So let's replace the cosine 2x with something favorable to me. I already got a cosine squared there. So let's replace the cosine 2x with stuff that's also cosine squared. Because remember, I have 3 choices. So again, like I chose earlier, I'm going to choose this one again, just because it matches my problem. So I'm going to replace that with 2 cosine squared minus 1. So I'm replacing this with 2 cosine squared minus 1, and it equals 1/2. All right, so let's see what we got. We got cosine squared minus 2 cosine squareds. Minus minus makes plus 1 equals 1/2. All right, so a cosine squared minus 2 cosine squared is negative 1 cosine squared. Move that 1 over to the other side. So 1/2 minus 1 is negative 1/2. drop the negative, so I get cosine squared equals 1/2. Well, take the square root. So I get cosine is plus or minus the square root of 1/2. So I get 1 over radical 2. 1 over radical 2, if you rationalize it, becomes radical 2 over 2. And look at that. I'm not going to write the answers again, but look at how they match. One is the cosine radical 2 over 2. It's 45. 135. 5 pi over 4. And also it's plus or minus, so it's also down here, 7 pi over 4. And look at these answers. They take care of that. So it's pi over 4 plus pi n. Well, that takes care of this and this. And then it's 3 pi over 4 plus pi n. So that takes care of this and this. Okay? So, and if you got down to here, you could just say each one of these plus 2 pi n, or if you realized you could write it this way, you could write it that way. All right, so let's get to our last things here. So, sine half-angle formulas. So these are the worst, the absolute worst. But we'll just do them to say we did them, and you don't use these that much, but we'll just do them. All right, so theta over 2, remember, they're just formulas. So what this does is if your angle is half of something that you know, we'll get to it down here. So write this down, plus or minus, put a big radical because there's going to be a fraction inside. The top of the fraction is 1 minus cosine theta, and the bottom is a 2. Over here, put plus or minus again, big square root. This time it's 1 plus cosine over 2. So kind of similar to these up here, but then of course if you put these over each other you get the tangent, so put plus or minus, big old radical, 1 minus cosine over 1 plus cosine. All right. All right, so here we go. The sine of 105. So the sine of 105. 105 is half of 210, right? So 1/2 of 210 is 105. So 105 is really 210 over 2. Because I don't know anything about 105, but I do know 210, and so that's what we're going to do. I'm going to put 210 right here. 210 over 2 is 105. All right. And so then I can use 210 in my problem. So here we go. Now, another thing that sucks about these things too is that you have to decide the sign. You see these have plus or minus? Well, think about 105 degrees. 105 degrees is over here. If you're doing the sine and you're in the second quadrant, well, you are positive. So I'm going to use a positive and write my big radicals. Now we're going to do this. So 1 minus the cosine of 210 over 2. Okay, so a big radical. I'm just going to clean this up. The cosine at 210. Oh, let's see, 210. Whoopsie. Cosine of 210 is radical 3 over 2, but it's negative. So minus a minus would be plus radical 3 over 2 and over 2. All right, so we're just going to clean this up just a little bit. I have a big radical, I have a 2 on the bottom. Let's get a common denominator here. So 1 in terms of a denominator of 2 would be 2 over 2, right? 2 over 2 plus radical 3 over 2. So my denominator is 2. So I have basically 2 over 2 plus radical 3 over 2. That's what the top is. So I have 2 plus radical 3. Right there. Okay. So, like I said earlier in this chapter, we can like slide this out front. So I got a big radical. These 2's kind of they combine together, and I got 2 plus radical 3. There we go. Okay. So let's do the tangent of 105. which is like doing the tangent of 210 over 2. Alright, so 105 is up here, the tangent's negative, so I'm going to take a negative sign, and I'm going to put these in. So 1 minus the cosine, that's going to be the exact same thing I was doing right here. So I think I'm going to steal this information, 1 plus radical 3 over 2. And on the bottom, I got 1 plus cosine, so that'll be 1. Remember, our cosine was negative, so that'll turn into minus radical 3 over 2. Okay. Negative sign. Right. So this top part will be 2 plus radical 3 over 2, like we did earlier. The bottom part will be 2 minus radical 3 over 2. 2's cancel, so my answer is negative, big radical, fraction, 2 plus radical 3, and 2 minus radical 3. Now there are various ways to write that neater, but let's just not. Alright, sorry. Okay, last one. We're going to solve here. So, again, you can hopefully get the idea that this is what I'm going to be replacing here. So let's do it. And notice that it's squared. So, it's this formula, but it's being squared. So my radical is going to disappear. So we'll write that out. 2 something squared. The thing that I'm squaring is this item right here. Square root. Put plus or minus 1 plus cosine theta over 2. So it's the formula that we did today, but it has a square on it, so that's why we're squaring that radical. And so that makes the radical go away. So 2 times and then 1 plus cosine. How convenient, right? Okay, so my 2's cancel. And so I got 2 minus sine squared equals 1 plus cosine. So now we're, oh, I'm sorry, you couldn't see any of that. Sorry about that, my paper is too low. Alright, so I plugged that in, plugged in my formula from up here. It was squared, so it knocked these out, and squaring a plus or minus makes it positive. So these 2's canceled, so I've left here. Alright, so I combine, 2 minus 1, I'm going to reduce that down, but sine squared. I can't do a sine squared and a cosine. So I'm going to replace my sine squared with 1 minus cosine squared. So that way I can factor later. Alright, here we go. So 2 minus 1 minus minus makes it plus cosine squared equals 1 plus cosine. Alright, 2 minus 1 is 1, and I got a 1 over here. All that goes away. So I got cosine squared. Let's bring this over with me. So now I don't even have to factor with 2 parentheses. I can just do the GCF. Cosine theta and cosine theta minus 1. I pull out a cosine. Alright, so here we go. Cosine is 0. This is a long one. And here cosine equals 1. So this says solve. We'll just say 0 to 2 pi. I didn't say it there, but I guess actually we should probably, since it didn't say, we're just going to do all the answers. So cosine is 0 at 0 and 2 pi. I'm sorry, at pi over 2 and 3 pi over 2. So we'll say pi over 2 plus 2 pi n. And we'll say 3 pi over 2 plus 2 pi n. Now we could condense those and say pi over 2 plus pi n. And when is cosine 1? That happens at 0. So we'll say 0 plus 2 pi n, but I could just say 2 pi n, because 0 plus 2 pi n would be 2 pi n. Alright, and so that is it. We will work on these in class next time, and make sure you work on your corrections, and your section 5.4, make sure that's done. Bye-bye.